Hey everyone, and welcome. So, you ever feel like chemistry is just this secret code? Well, today we're going to crack it. Let's dive right in and talk all about chemical reactions and equations.
Think about it for a sec. Doodh se dahi, milk turning into yogurt. Or when your bike chain gets all rusty, lohe pe zung. We see this stuff all the time, right? But have you ever actually stopped and wondered what is really going on there?
You guessed it, it's all chemistry in action. So chalo, let's become detectives for a bit. We're going to decode all the secrets of chemical reactions, taking it totally step by step. It's gonna be fun, I promise.
Alright, so let's start at the very beginning. Pehle Kadam, our first step. We need to figure out what a chemical reaction even is.
Okay, so a chemical reaction is basically a process where some stuff changes and forms completely new stuff with totally different properties. And here's the most important part. It's a permanent change. Like you can't unburn a piece of paper, right? Once it's ash, it's ash. That's a chemical reaction.
So every reaction has two main players, the reactants and the products. Just think of it like baking a cake. Your reactants are the ingredients, the flour, the sugar, the eggs. And the products? Well, that's the final dish, the yummy cake you get at the end. Simple, isn't it?
So, how do you even know a chemical reaction has happened? You gotta look for the signs. Yad rakho, remember these clues. Maybe there's a change in state, like a solid turning into a liquid, or a sudden change in color. Maybe it gets hot or cold all of a sudden, or you see bubbles of gas. These are all huge clues that chemistry is at work.
Okay, are the basics clear? Awesome. Now let's get into how we actually write these reactions down. It's kind of like learning the official language of chemistry.
A chemical equation is really just a cool shortcut. Instead of writing out a whole long sentence, we use symbols and formulas to show what's going on. So, like A plus B, arrow, C plus D. It's way faster, and it's how chemists all over the world talk to each other.
Now, I'm sure you've heard your teacher say this a million times. Balance the equation. Don't forget to balance. But why? Why do we have to do that? What's the big deal anyway?
Well, it all boils down to this super important rule of the universe. It's called the law of conservation of mass. And all it says is you can't just create stuff out of thin air, and you can't make stuff disappear. You can only change its form.
So because of that law, the rule for our equations is super simple. The total weight of your ingredients, the reactants, has to be exactly equal to the total weight of your final dish, the products. And for that to happen, the number of atoms of every single element has to be the same on both sides of that arrow. That's it.
Let's look at a classic example, making water. The basic or skeletal equation is H2 plus O2 gives you H2O. But wait, look closely. We have two oxygen atoms on the left, but only one on the right. See, it's not equal. So we balance it. The correct version is 2H2 plus O2 gives you 2H2O. Now, if you count them up, we have 4 hydrogens and 2 oxygens on both sides. It's perfectly balanced.
You guys are doing great. Now that we know how to write and balance equations, let's meet the whole reaction key family. There are a bunch of different types, and each one is unique.
First up, we have the combination reaction. This one's easy. It's when two or more things combine to make just one single thing. A plus B comes together to form C. It's kind of like two people meeting and starting a new friendship.
And right on the opposite side, we have the decomposition reaction. Here, one single thing breaks apart into simpler pieces. It's the exact opposite of combination, almost like a breakup. AB splits up into A and B. But, this kind of breakup isn't always easy. It needs a push. It needs energy. And this energy can come in 3 main forms. You can use heat, that's called thermolysis. You can use electricity, we call that electrolysis. Or you can use light from the sun, and that's photolysis. So for a quick example of thermal decomposition, check this out. If you take lead nitrate and heat it up, it breaks down into 3 different things: lead oxide, nitrogen dioxide, and oxygen gas. One compound just became 3. Pretty cool, huh? But wait, there's more. The reaction family is even bigger. So let's meet a couple more members. Already reactions. Next, we have the displacement reaction. This is where a more powerful, or what we call a more reactive element, comes along and kicks a less reactive element out of its spot. So you see here, A is the stronger one. So it pushes B out of the way and makes a new compound with C.
So how do we know which element is more powerful? Well, chemists have a list for that. It's called the reactivity series. Basically, Any metal higher up on this list can displace any metal below it. So potassium, up at the top, is the boss. It can kick pretty much everyone else out.
And last but not least, we have the double displacement reaction. This one is like a partner swap at a dance. The two compounds literally exchange their partners, their ions, to form two completely new compounds. A ends up with D, and C pairs up with B. Everybody gets a new partner.
Phew. Okay, that was a lot of theory. You might be thinking, why does this all matter? Well, let's connect it all back to real life. Let's look at the chemistry around us.
Two perfect examples are corrosion and rancidity. Corrosion is just a fancy word for when metals get eaten away by stuff in the air, like rusting iron. And rancidity, that's what happens when food with fats and oils, like your chips, go stale. And hey, you know that air in a bag of chips? It's not just air, it's actually nitrogen gas. They put it in there to stop the chips from reacting with oxygen and going stale. See, chemistry is everywhere.
So, you see, chemistry isn't just some boring subject in a textbook. It's happening all around you, all the time. Now that you know the basics, I have a challenge for you. Look around. What other changes do you see every day that are actually secret chemical reactions just waiting for you to discover them? Go on, have a think about it.